Tusha, Chairman and Managing Director of AB Groups actually, right, Chennai. And today's session is going to be like a fascinating session topic actually, like the machine and deep learning for the video processing for the startup. On this video analytics part, and we are working on kind of an algorithm for the different devices on a particular IoT kind of stuffs, and most importantly, the AI-based applications. So we are going to be like talking about my experience about a lot of the product development on how to choose the algorithm and how to work on the algorithm for the machine and the deep learning mechanism. And what is the exact problem we are facing today? Actually, we have been facing a lot of problems actually in a video processing and video analytics. So we are going to talk about how it is going to how you are going to proceed with the kind of thing and the challenges what we have today, right? So let me start. It is not going to be like presentation, PPTs, right? It is going to be like the whiteboard discussion. Actually, we are going to have a whiteboard discussion with you guys, in which we are going to start and we are going to talk about different scenarios of algorithms and the implementation and the deployment. And what is the deployment? We are going to see about how it is deployed in a particular application. We are going to see one by one. And the second thing is about we are going to have some case studies where through which we are going to calculate. We are going to see what is behind this learning model, how to choose this learning model, and for this kind of an application. So these are all the things which we are going to talk about today, and then we are going to proceed forward for some of the applications. Right. So let me share my presentation right now. Okay, so I hope my presentation can be seen by everyone here, right? So machine and the deep learning for the computer vision system, or we can say it's for a video processing, how it is being done for the video processing. So before moving on to this kind of an application, you may aware about this machine deep, a lot of algorithms practically, and you'd have seen a lot of applications. Now this is going to be some different cases. What is the exact thing what you have been following in the case of your vision system, right? So before moving on to this, let me, if you want to know more about us, this is our website. You can very well refer our website, that is abgroups.com actually, right? And let me start the basic foundation. The first part is going to be the basic foundation, and then we are moving on to the challenges what we have and how this machine and deep learning can solve the problem. So this is the logic which you are going to take over it, and finally the deployment, where it is deployed and what is being deployed. So everybody aware about this word, right? These artificial intelligence, machine, deep learning, everything, right? So these are all the terms which you are being aware about all sort of years, and it will be going to rule the world for the next 15 years. So this is what is being done over here. My basic thing is whenever you start working on the vision system, not only on the vision system or kind of a video processing, in any domain, when you want to start your application on AI for a different domain. So my first suggestion is, first step of following your AI-based design is this. So you can use this design for any kind of an application. So first is about we must aware about the data model. The first thing is about the data model, what we have to take care about it. Second, where do we store it? Whether we have to store it in the cloud or where to store it in a server or something on in a SD card when you put on the hardware. And finally, we have to select, there comes the learning logic. That is, we need to go for the feature extraction and we need to go for the intelligent learning and the decision box. So these are the 5 things which we have to take care about it once you start doing any kind of an application. So first, let me start with the data model. So the videos, how do we process the videos? The first challenge what I want to post over here is, let me share my PP whiteboard session actually, right? Yeah. So first thing is about we have to think about whenever we are working. So we saw there is a data model, we saw there is a storage, and we saw some of the things is your feature extraction, and finally we saw something on the machine and deep learning, and finally we saw something on the decision box. So these are the 5 important things, and I'm going to define this before moving on to the definition. Like we'll post what are the challenges in the video processing, right? So challenges. And before that challenges, like we have the definition for you, that is data model. So the data model is present over here. The data models are present over here. In this case, we are going to work on the cameras. We are going to work on the camera inputs, right? So we want to make an input camera inputs, right? So what is the first challenge what we have here? First challenge what we are developing today is we need to develop the algorithm. That is the most important cases. We need to develop the algorithm so that it is resolution independent. The most important thing when you start doing it, this is the most important mechanism, the resolution independent, and independent of the, in short we can say it is an independent of your camera manufacturing, right? So most important, we need to develop an algorithm, we need to develop a model in which my model should able to react for the different cases of the resolution. It is not that we have to develop an algorithm only for the certain application. We can't say that it has been applied only for it is utilized for this kind of resolution or this kind of resolution. It is not so. So my algorithm should work on the different categorization of a model. So that is the most important scenario what we have right now. So we need to develop that. We need to develop this kind of an application, the resolution independent mechanism. And the second point regarding this is my algorithm should be like, or my model, the developing for the model should be like compatible to my any environment. This is the logic. My model, again, once you go for a resolution, okay, we design it, but it should work for any kind of an environment. So this is what we are seeing in our mobile phones. So the model what we have to develop should be compatible to any environment, and it should take it with a similar mechanism. So this is the most important criteria what we have. And third application regarding the video processing is that is the selection of the CPU is important. The selection of CPU is most important to process your videos. This is most important thing what we have right now. For the processing techniques, we need to implement this kind of an application. And the video processing technique should be like, it should be vary from the different mechanism. And finally, the kind of a storage what we have, the kind of a storage. Because why? Because in today's scenario, we don't have any model for the live streaming. The training model of the live streaming video is not there. What we have to do is we have to load the mechanism, load your videos, and then we need to go for the training methodology. So this is what the logic is being taking place here. So, but the kind of solution and the kind of challenge what we have is we need to develop a training model for the live streaming of videos. That is the most important cases. So these are the four important models, important challenges which we have today. That is to develop your machine and deep learning for a mechanism. That is to develop an algorithm so that my algorithm and my model should be resolution independent. My algorithm should work on any kind of a camera, and it can be compatible with any kind of a cameras as well as the environment. So this is the two important cases what we have to take care about it. And third is about the selection of CPU. It's most important. Selection of CPU is most important because we'll talk about the CPU right now. So for a processing of a video, we won't fix up these cameras and makes out. So here there is a logic which you have to be taking care about it. That is the selection of CPU. So all the video processing technique has to be decided whether to be in any CPU or in kind of a storage devices, and the kind of storage what we have to take over it. So here in the storage, what is the problem we are facing today is about training the model for the live streaming of videos. When there is a live streaming of videos, there is no kind of a model which is present over here, and then there is a kind of what you call like what is being traditional happening here is we have to load the video and then we have to train it and then we have to do such a kind of an application. But in case of that, in the industry scenario, as far as the startup is concerned, we need to go for the live streaming. The training model has to be prepared, or it has to detect some of the live streaming of a mechanism, live streaming videos. So these are all the things what we are facing today for the video processing. So these are the things. Please remember, these are all the things which we are going to develop it. I'm going to see how it is going to be developed also. So this is the logic which we have to take care about the mechanism. And then how to prepare a data model. This is the logic. So first challenges, and then we have a data model. So for this application, I suggest you to go for IoT based application, IoT based video processing. So this is the logic I used to go for you. So the IoT based video processing is required. So when you draw the block diagram, there comes the camera, and then we need to select one CPU, and then any IoT transceivers. So here it may be an LTE or it may be a Wi-Fi or any case, right? So this is the logic which you have to take care about. So the camera, as we talked about, it is resolution independent, and the camera what we have here is, I suggest you to go for uh, high-end cameras for real-tech cameras, which is used nowadays. Okay, so real-tech cameras has been now used in real-time mechanism where it has to process all sort of an application. So here, this is the most important cases what we have to take care about it. So we need a camera and the CPU and an IoT transceiver. So this data model, if I just go for the CPU selection, what kind of CPU you can select for this? For the first kind of a CPU model, when you want to go for a video processing, I used to go for the Cortex A53 processors or A57 processors. It is going to be like that. So you can choose this Cortex A53 or 57 processors, and you have another category which is being used for this. This is RISC-V architecture. Most importantly, it is, we'll talk about later what is all this thing. So RISC-V architectures, and third thing is about you need to go for, like, if it is not being supported, you can go for any kind of an FPGA. That is programmable gate array, and you can use any kind of a board with that. But I suggest you to go for start with the Zinc model. So Zinc boards can be started over here. So Zinc boards can be started over here. So I suggest you to go for this kind of an application in the Cortex A53 and A57 processors and RISC-V architecture and the Zinc 5 boards. Okay. So what are all the things for the Cortex A? You can choose for NVIDIA Jetson Nano. And now RISC-V architecture, you can use MaxiPi boards. And then we talk about this. This is the Zinc and the logic, right? So these are the boards which is used to make it out. And regarding this processing, so the next thing is after selection of the mechanism, you need to select where is your processing, selection of processing. That is whether you're going to process in the hardware or in the storage. This is what the logic. So whether you're going to process your things, everything in the hardware or in the storage, what we call as a CPU or CPU, or in the, we can assume here we are going to work on the cloud, right? So for the storage, data storage, right? So this is what the logic which we have to take care about it. So here we have to take care about it. This is the logic. So whether I use this camera interface with the Cortex, I used to implement my machine learning and deep learning algorithms on the hardware itself and send the results to the cloud, and the output can be obtained in the mobile app. Is this the condition? We are going to follow this, or this kind of Cortex architecture will use to grab the video and transmit the video over the network, and there we do the analytics. So there are the two options to implement your model. So first model is hardware centric. So the hardware centric is nothing but everything is on hardware. This is the logic. Everything is in hardware. So this is a little bit complex actually, but still we can do it. Everything is hardware centric. It is a compact device. So what you call is, like, I have this camera and all the processing, that is the video processing and everything, can be taken place on my hardware itself. So this is the logic. So hardware itself, it is going to be the hardware itself. Next is about your cloud centric or a storage centric. So what I do is the hardware which I utilize, the CPU which I utilize, used to transmit the video to my cloud, and there I just integrate all my models. Hope you have understood. So these are the two important categorization to work on the video processing for the mechanism. So the deep hardware centric or cloud centric, what is going to be adopted, we have to select, but each one of them have their own challenges with us. So when you talk about the hardware centric, that is completely different. Why? Because yes, you need to know about the architecture and the mechanism and everything. When you go for a cloud centric, you know about the what are the models which is supported and how it is being utilized. So this is the scenario system model to develop your mechanism. So all the feature extractions and your learning models can be integrated in this stuff, can be integrated with this kind of a stuff. So we need to understand clearly. So this is the logic, which is the basic primitives which is being required to design your video based mechanism. So video based application. But repeat once again, these are all the challenges what we have, and the data, we are going to prepare a data model, and that we are going for IoT based video processing. So I just go for this. The first model or a challenge itself, we have to propose an algorithm so that it is a resolution independent, and it is IoT based video processing. So for the data model is selected, camera, CPU, and IoT transceivers. Here, the modeling of data depends upon two mechanisms. One is hardware centric and second is your software centric. Hardware centric is working on all the video processing and models, designing of models based on these architectures. So Cortex A53, Cortex A57, and RISC-V architectures and FPGAs. So this is all about, we do the development here and just output on the cloud. But whereas there is another sector in which these boards are utilized only to capture the image and send it to my cloud system, where I just need all sort of my models or learning models to be integrated. So this is the two important scenarios once you start doing your video processing. Select your model which is to be developed, depends upon the requirement, but keep in mind about these 4 points. This is the most important 4 points once you start doing the model. So this is most important because you are working with the camera which is end-to-end dimension. So we must be able to work out all this kind of stuff. So please remember all these 4 points when you start preparing a video processing using a model. And then we have this kind of a mechanism. So data model is ready right now. And then the selection of CPUs, and the most important, there are two subdivisions. One is hardware centric and second is your software centric or a cloud centric. So hardware centric, which is going to be utilized, whether you are going to implement all your algorithms in your hardware itself and do the processing, or second is your cloud centric, where it is going to be implemented in the cloud. So this is all about the logic. So here we'll talk about this later after seeing the models. So how it is integrated in the model deployment. So this is the basic criteria once you start doing your video processing, and then we have to go for a machine learning model. So development of a machine learning model. So machine development of machine and deep learning models. So now I just go for my PPT. So we saw these are the things actually, right? So these are the things which we have making clear about all sort of application. So here, this is the logic. So database collection and everything. So this is where we subdivided into two important points. One is data model and the user inputs, and we have a database collection where I just collect all my datas over here, and finally we have a feature extraction. So feature extraction is there, and finally I just integrate with the machine and deep learning, and finally with the decision box. So here we should assume that we are going to for a hardware or a cloud centric. That is important for us. So in a cloud centric, this intelligent learning will be integrated in the cloud, whereas in the hardware centric, the intelligent learning on all these things will be taking care about in the hardware. So these are the two important points. Kindly remember this, and kindly remember the 4 important challenges what I told you, the video processing over the mechanism. Now the developing of a models, how to develop a models for this, right? Okay, so when you start exploring this communication, so we will be facing like this, how to develop a model and how to make a logic for this, and what stuff which we have to take care about it. So now this is the logic which we have to be taking care about it. So now we are going to, it may be a little bit complex or tricky when you consider this mathematical model. For the better understanding, I'm going to take the case studies from this film, right? My presentation deals always with this film. Actually, when we talk about ML and DL, this film was released in 2010, like starring superstar and Aishwarya Rai. Now because like this is the logic, like this film will have all sort of algorithms. Hopefully we have to solve in the algorithms, and then we are going to take about the applications. We are going to take about how it has been solved with the help of the algorithm. And this every system, every system or a concept which is explained in the film is basically purely based on the training models. So how it has been done and how it can be done with the help of an application. So we are going to take this case study from this film, and we are going to see a clip of video for 2 minutes, and then we are going to derive the problem. We are going to see what is the problem and what is the solution can be brought over here. So this is what we are going to derive for the deriving of your machine learning model. So before moving on to the machine learning models, so let me explain you clearly machine and deep learning. You may aware about all these things, but let me explain with one point. When the volume of data, see when you go for a huge volume of data, please go for the deep learning algorithm. And when you have a low set of low volume of data, you can go for the machine learning algorithm. When you go for the large volume of data, when you go for a large volume of data, you can go for huge volume of data, you can go for a deep learning. This is first mechanism. And the second mechanism is the feature extraction. What we talked about should be done manually and should be combined with the machine learning. The feature extraction, which has to be done manually, and then it has to be extracted with the machine learning. But whereas in the deep learning, we have the feature extraction integrated with that. So it reduces the complexity. So this is the logic which we have to take care about it. So first thing is about, these are two important points when you go for ML and DL solution. So please remember, the fifth points to remember after the data model is selection of your model. The selection of your model, please choose your volume of data, and depends upon the volume of data, please choose your model which is required. Now we are going to see about one case study number 1. So the case study number 1 is going to be dealing with, I'll show you the video clip, then we will solve it, how these models can be designed with the video processing. So this is the case actually. Kindly watch this film actually, kindly watch this video. So you have watched this. Let me go for solving this problem actually. Um, can anyone say what is the exact problem in this video actually? Can anyone reply me what is the exact problem in this scene? I need some interaction actually. Any answers? Any answers, guys? So what is the exact thing which you have seen? This movie you would have seen so many times from the movie, in the TVs, anything, right? So what is the exact, you would have seen this identifying mechanism, right? So what is the exact problem? Can anyone tell me actually? Can you make me a message also? The problem in the video, what you have seen in the case study. No answers. Right. So I'll explain it. First case study. First case study, what we saw here is it's a complete video processing analysis. We will solve it in the help of a machine learning as well as in the deep learning. First, like this is the solution regarding the hardware centric and everything. But here in the case study number 1, so we need to find out an output. So the model which is required is you need to identify the mechanism is most important. You identify the human from similar robots. This is the logic. So need to identify the human from the similar robots. So this is the logic. So here we need to identify the similar. My camera, this is where the camera resolution, independent resolution algorithms are required actually. So the first thing is about like you need to identify the human from the similar data. So this is the logic. So we have only similar data. When you saw in the movie, you have only 100 data and the 100 data are very similar. It is not like we have like 50 data for the human and 50 data for the robot. That is not the case which is done over here. So you must understand clearly that the data model or a mechanism which we have to take care. The exact problem here is like we need to identify the human from the similar data. All the data are similar, but it has to identify from the mechanism. So this is the logic. So now we go for the steps in the video processing. What it takes is when you saw this, there will be some the feature extraction. So like what happens here is we need to go for the feature extraction. So whenever you start doing it, so I just convert all your videos into frames. All your frames will be converted, that is image frames will be converted, and we need to go for the processing. And then I need to go for the segmentation, and then I need to go for the feature extraction, and then model, and then classify. This is the logic which I have to go for it. So this is the mechanism. So here the videos converted to frames and then converted to the segmentation, and then we have to convert your features into a maps, and then we need to design a model, and then we need to go for a classification. So this is the logic. Classification, here we have a problem. That is, one problem is something on we have to identify clearly that it has to make a difference of data from the similar data. It has to make an understanding that from the group of difference data, it has to identify the similar data. This is the logic what we have to come across here. So this is the logic what we have to take care about the mechanism. So here, what is the solution which we have to bring, and what is the mechanism which we have to take care about it? The first thing what we have to take care about here is, it's a very simple algorithm, but still, the thing is segmentation. Here the segmentation is done. The segmentation is done based on the background separation. So here we have to go for the background separation, and we need to segment which image is required. So segmented image must be able to replicate what is the exact thing. So it should replicate what is the exact thing. So this is the logic which we have to be taking care about this mechanism. So this is to be done clearly. Background images, and will give you a segmented image. So for this, I suggest you to go for a methodology. Even though you have a lot of algorithms which is present over here, I just used to go for this silency maps, implementation of silency maps for segmentation. Hope you have, this is something, a technique which is being utilized, because this silency maps is not only utilized for this kind of an application, it plays a most important role in the medical video analytics also. When you are working on the medical video analytics, this kind of maps can be utilized for a better segmented images. You have a lot of algorithms such as edge detection, so well, you have different categorization, everything. But still, I suggest you to go for a silency maps, because for the better extraction of your mechanism, because in ML model we don't have this kind of an application. So after segmenting the robots, only the record robots, because you would have seen in the movie that only certain robots are taken into the back. So that certain robots have been taken trial and method, and for that selecting the subtracting the background robots from that the robot which is to be tested can be done with help of a silency map. You can refer it. It's a silency map is the most important filter, but it is more powerful. And then we have to go for the feature extraction. This is the logic which we have to be taking care. In the feature extraction, you would have seen that different thing, body scanning, and then you would have seen this cutting of there will be a cutting of the human body. Then you can see, let us assume sweat, and let us assume like there will be a breath control, and then we can have the rotation of the head. These are all the features which are extracted. These are all the features which are extracted. It depends upon the application. You can take the features which is required for you. So this is the logic. So features has been extracted for a kind of an application. Now we have to design a model. Now the logic which goes for is designing of a model. The model which comes into the application is very simple. Actually, we have to go for a separation. That is, there are categorization of a model. One is supervisory model and unsupervisory, and then we have reinforcement. So here we have to design which model is going to be selected, which training mechanism has to be selected. Now supervisory model is nothing but we have the inputs and outputs are known. That is the logic. So please find out this when outputs are known to you or known, we can go for a supervisory model. So this is the logic. It's a supervisory model. When I know only about the inputs, I will go for a unsupervisory. It is not, it is utilized in a case of your feature mechanism. Or feature extraction or pre-processing, whatever case it is utilized one in this case. Here the input is being utilized as a training model, right? So the inputs, when the inputs and outputs are known, when the inputs and the outputs are known, we are going for a supervisory model. And only the inputs are known, I don't know about the outputs, then certainly we need to go for a unsupervisory model, right? And then reinforcement, it is the next level of supervisory. We'll talk about later about the reinforcement, because in today's world everyone is working on reinforcement learning model. This is the logic what we have to come across here. So that is the mechanism, we have to take care about it. And this is the logic we have to take care. This is the logic which we have to take care about the mechanism. So now the logic which comes into the picture. So the logic which comes into the picture, now we are going to design a model. Here in this scenario, this case study, we are going for a supervisory model. Why? Because is in the supervisory model, in the problem what we have talked about, the problem is know what we have 100 robots, input is known and output is known. That is, we need to identify the human. So output and inputs both are known. So we need to go for a supervisory model. So this is the logic. If I don't know the output, if the Vasigaran is not be known, I need to do with among the clustering. Okay, based on this logic, I need to go for the unsupervised. Reinforcement is something different, which is not suits for this case study here. So now the logic which comes into the picture here is the logic. We are going to use supervisory since input and outputs are known. So now this is the logic. So we have to integrate a silency which separates your foreground image and the sigma, your tested image. That tested robot has to be taken over here, and then we are just integrating with a feature extraction and the film which shows you the different features such as body scanning, cutting, sweat, breathe, and the rotation of head has been taken as the different features. And the supervisory model, we fix up with the supervisory model. Why? Because this supervisory model is known with the input and outputs. Because we know the input and outputs are known, so we fix up with the supervisory model. Now, how to prepare? How the training model has to be prepared? So, preparation. Next step is preparation of a training model. Now, preparation of training model, I need to make the machine to understand. So the features have extracted, very good, right? But how to make your machine to understand for the supervisory mechanism of learning? So I prepare a data model here. I'll just make it. First thing is out. Since I just only two outputs are required, that is either outputs 1 or 0. So 1 is something on like what we called as for the robot. We'll assume 1 for robot, 0 for human. Make it as this as an outputs. The logic which comes across here is after extracting the features, we have the thresholds, right? Let us assume we get right less than 1. Sorry, if it is equal to 1, I'll go for a robot. If it is 0 to 1, I'll go for a human. So this is some values which I have to calculate manually. Let us assume for the robot number one. Robot number one, the features what is extracted here is 5, right? So body scanning and sweat, breathe, and as well as what you called as cutting of things, and then we have this rotation. So what happens is, let us assume the first robot. We have 100 robots here. Body scanning. If it scans the body, please watch my words. If it scans the body and it finds it is a metal, it finds it is a metal. That is, a robot will have the metal body. I'll make it as a 1, right? And then if there is no sweat, make it as a 0. No breath rate, 0. Cutting of that, if there is no blood, if there is like wires, I'll make it as 1. Rotation, it can able to rotate at 1. And this is for 100. But for a human, it is going to be quite different. Body scanning, I just make it an opposite value. 0, there will be a sweat, and there will be a breath rate, and cutting of it will be a blood, 0. And we can't able to rotate 360. This is the data model. And how to make understandability, that is label, we need to go for a label. The label, we have this. And I'll just split it up for 1 for a robot and 0 for my human. So this is the training model. This is the training data model that has to be fed to my machine to understand, because you can see here all the data are fixed and the output is fixed. So this output is fixed actually, right? You have a fixing of outputs and all these things are being fixed, and you can make the machine to learn and understand. So this is the logic. So next phase is ready. So you have to work on this. So I just assume for ones and zeros, but they may be some having the numerical values. By understanding the numerical values, you can able to label the data. This is the logic. So if suppose I am having the 0 to 1, that's all. But here you may have the numerical value. You need to check with the threshold what you have kept, and with the help of the threshold, you can able to understand and you can able to make it with the help of ones and zeros. Now the logic here is the next point. How to choose your model. So the model selection is very important in the case of here. The model selection is important. Now you can understand from one single thing. That is, body scanning, it fails actually. It can't able to identify from the sweat, it can't able to identify from the breath, and even the cutting, it can't able to identify it. But it is identifying with a single feature, and that is rotation of head. So we need to understand clearly. We need a model which can able to understand from one single distinct feature. I repeat once again, you have, even though the 5 features are there, but still, if all the 4 features are failed and one feature, with the help of one single distinct feature, my model has to learn and give the solution, and you should do the classification. That is being done with the help of support vector machines. This is the model. You can make a learning with the single distinct features. It is used to identify with a single distinct features. The support vector machine. This is the most important case what we have right now. So hope you have understood. It is a powerful, but it is older one. But still, I said it has been now integrated in all sort of algorithms. So the support vector machines, which can able to learn with the one single distinct feature. And that has been done with the help of the SVM. SVM is preferred. So you can see that all the 4 features fail, but it can understand only with a single feature. That is known to be the SVM logic. That is the concept what we have known to be the SVM concept. Right. Now, hope you have understood. When you do the mathematical order, mathematical mechanism, like let us assume the y-axis will have the robots. That is the feature what I told about the robots. And x-axis will have the features of your human. And when you draw the hyperplane, right? When you draw the hyperplane, right? When you draw the hyperplane, you will get the rotation of it as a single distinct feature very close to the hyperplane, and SVM learns from that. So this is the logic and why I preferred for a SVM based mechanism. This is the logic which we have been taking care. We have to take care about. Sorry. So this is the logic which we have to take care about it. So SVM and the learning mechanism. SVM is supported only because of you have to understand clearly, like it should learn from the one single distinct feature. It should learn only with the one distinct feature. It should learn only with the one single distinct feature that will prefer SVM. So this is the procedure, guys. We have to Implementation, we'll see how the programming has to be done. So here you can see here, this is the methodologies which I have to retain. So here I need to go for a background separation, silencing map, calculate your feature extraction manually, and then select your model, training model. I prepare a train supervisory model and prepare your data which the machine can understand. And then finally, since the problem is you have to identify the one single data from the similar data, I suggest you to go for a SVM, because SVM can learn from the one single distinct feature. So that is the most important case why we use this. This is an example how to deal with the machine learning with the video. So this is the logic. So you'll have a huge data. So huge data for this, because when you have the frames as converted, and each and every frame we have to convert it and see what is happening. That is the complexity what we have right now. So this is the logic what we have to take care about the mechanism, right? I've shown you an example, but still you have a huge data to work on this. So this is a machine learning kind of an approach. One thing is machine learning kind of an approach. Next is about deep learning kind of an approach. Deep learning models. How to make a deep learning model. So this is the next criteria what we are going to talk about. This first is, hope you have cleared it. Any doubts up to now? Any doubts, guys? Any doubts? Because like we are moving on to the next model, deep learning model. So hope you have understood, right? Hope we can assume that you have understood actually. Now we can go for the next model, preparation of your deep learning approach. So the deep learning approach, what is the deep learning model which is required here, right? The next application is deep learning model. The deep learning model is nothing but it's a classification of, or it is a category of ANN, that is artificial neural network. Artificial neural network. This is the logic which we have to take care about it. So this is the mechanism which we have to take care about the mechanism. The artificial neural network, we have to take care with the mechanism, and we need to provide this mechanism for the logic. So how to make it out with this mechanism, and what are the logics we are going to take about here. So deep learning, nothing but when you talk about an artificial neural network, it resembles your brain. So input layer, and then the brain is there, and then there is an output layer. The logic which comes into the picture here is, so instead of the input feature vectors, instead of brain, we don't know what is happening in the brain processing, so we call this as hidden layers in the outputs. And then we have this output. Output is your classification. This is the logic. So input layers and hidden layers and the output. This is your ANN actually. This is a concept of an ANN. But when we have this deep learning concept, I'll just go for this definition. Deep learning. What is exact about the deep learning? So I just added. So hidden layers plus hidden layers. In order to make you to understand, we go for a simple example. When we have this, when you want to make your students ready for the examination, and the training methodology depends upon the capability of the brain and also is capable of getting a good marks. If the student, not a teacher, if a student decides himself that he has to get only 50 marks, he will study accordingly. The hidden layers will be less, because he will concentrate only on the important questions. He will concentrate about the repeated questions and so on. So the storage and the training mechanism is very simple, because you need to train only on these questions, and the pass percentage is your accuracy, 50. But if you want to make him to study and get 100% of marks, the methodology will be a little bit different. we will make him to understand, and we will make him to write numerous tests, and he will be writing on the reference books. He will be studying on the different books. It keeps on going on it. So the large number of data is required in order to get the high marks. So that is the line which differs from the artificial neural network and the deep learning mechanism. So the deep learning, this is the second case what we talked about, is the deep learning logic. The deep learning is something like we need to integrate numerous hidden layers to train the large data so that the accuracy or the performance is maintained at a stable level. The performance is maintained at a stable level. And the first thing is about when we have concentrating only on the little bit data, that is the training data, is very less when we get a 50% of marks. When we want to make him to get it update to 100%, this training methodology will not be suitable. Hence we need to go for a different kind, and we have to increase the data to get a good results. So that is the concept of deep learning. So artificial neural networks, when I increase the numerous number of hidden layers in accordance with a huge number of data, we can call this as a deep learning. There is being converted into a deep learning logic. So hope you have understood what is a deep learning is. Now in the deep learning concepts, so this is a deep learning concept. There is a different categorization of deep learning model. One we called as for a kind of a video analytics. I suggest you to go for CNN or JN. This is the models which I want to prepare. So CNN, it is convolution neural network. And GAN is general adversarial network. Most important, so these are the things which we are working on. So if you want to go for a kind of an application and working on a kind of a stuff, what we have, so you can choose these two models. Out of this, you can choose these two models. And convolution neural network was a little bit easier to use. GAN, a little bit complex for the usage. So when you have this, but the term of accuracy, what we talked about is it depends upon the images, depends upon the images what we take and the videos what we take. So this is the logic what we have to take care about it. So let me talk about the CNN. So what is CNN? Everybody will be aware about what is CNN. Let me explain this in our methodology. So the same scene, same case study with of a CNN, how it has been done. CNN is a combination of the convolution extractor along with the neural network. Hope you have understood. So you have two parts to work in CNN. One is the convolution features, and second is your to work on the neural network. To work, it consists of a neural network for the training. It consists of neural network for the training mechanism. So here you have the two options to do this kind of an application. So you have two options for the doing this kind of an application for the logic. So you have to understand clearly. So convolution is normally utilized for a feature extractor, and the neural network is normally used to train your model and train and do the application functions of your mechanism. So this is the logic which you have to take care about. Now let me have this convolution feature extractor, what has been done. So in the first case, in the first model, we talked about silency, feature extraction and everything. Now here we just take an image. Images have been taken into account. So the videos are converted to the image. The first part is about the filter banks. So consisting of your filter banks. Now let us assume you have the first frame is consist of 8 cross 8 pixels. So let us assume I have a matrix of 8 cross 8, 4, 5, something on that, and then we have a 3, 4, something on that, right? So I need to convolute this image into a filter banks. Filter banks can be any kind, 2 cross 2 or 3 cross 3. It can be a 2 cross 2, or it is a trial and error. You don't forget about it. There is your formula. It is all the trial and error. It is all the trial and error method. So I just go for 2 cross 2. Example, right? Let us assume values -1, -2, and another value which we have been coming across is -1, or right, 0 can't be there because it nullifies your images. So here, this is the logic. So now what happens is this filter has to be rolled back on my images or convoluted on my images. Hope you have understood. Convoluted is nothing but it should be shifted, it should be multiplied and added. Let me give you an example, right? This -1 and -2 and -1 and -2. Let me have, I will take this as a 1, 2. This is the first matrix, right? P, right? Will be multiplied and added with -2 and -1, 2. So hope you have understood what is the logic. So hope you have understood this is the logic which you have to be taking care about it. So this is being multiplied by this, and we will get first part, images number 1. The matrix, the images will be in terms of your matrix. So images will be in terms of a matrix. Next point is, again, 2, 3 and 4, 5 is being taken into an account. That is next level of row, that is 2, 3 and 4, 5 is taken into an account and again multiplied with the logic -2. And then you'll get another image number 2 in a matrix. This group continues like that. So it will be keep on increasing it. And you can see here it has been subdivided into each and every part. So all the noise factors and all these things will be removed in this matrix level. So it has been removed in this matrix level. It is to be done for 8 cross 8. Now you can imagine the complexity for a video. So it may consist different videos and stream it. So it has to be done for this, and we have these images for you. And after this logic, so we have another concept that is known to be the pooling layer. These images are then gone for the pooling layers. The pooling layers is being normally utilized for the segmentation. Normally utilized for kind of segmentation. You have the segmentation where all these images, whatever the parts depends upon you have different categorization of pooling layer. That is, the pooling layer will be a max, min, and max, min, linear, anything. So you have this kind of an application. Applying these layers on the pooling layer, you can segment the images. So the segmentation can take place with these images. There we have integrated a different methodology, but here in a deep learning, I can able to segment it from this application, then calculate a feature map and store it in a single dimensional array. So this is the logic. So you can make it out with the feature maps, and you can calculate with the mechanism, and you can store it in a single feature maps. So this is the layers what we have, and these all the layers have been like transferred into an activation function, and that activation function can be done with that is rectifier unit. What is this about? It is nothing but it maps your inputs according to the dense layers present and the output what is to be obtained. So this is most important. That is, this RLU has to be chosen so that it can able to give you, it can map your inputs according to the hidden layers, right? So this is the logic which is to be imported. So this is the mechanism. The feature maps is being extracted, and after this feature maps, the NN, this neural network, is being integrated for training and get the results. This is a logic and the training model which has been taking place. All these things are connected into fully connected layers. All these are connected as a fully connected layers. This is the most important, and this is the scenario what we have in the deep learning. So what I do is I just go for this. Again, this hidden layers will be different. For that depends upon the features what I accept. So the hidden layers will be large, and moreover here in this case depends upon the layers what we have. This is because in the filter banks depends upon the images and the outputs to be obtained. These layers will also be different. These layers will also be different, and from this it is also be like the fully connected layer will have this NN with the dense layers, and these dense layers will be utilized to train the model and give your output. This is the kind of an application what we have in the convolution neural network. This convolution neural will be like a layer by layer mechanism. First layer is filter, pooling, and your feature maps, and then a training, full connected in a complete manner, and this is called a fully connected layer. This, which is required in the filter banks and the dense layers, depends upon what is the accuracy of you are getting, and also the input features what we have. So based on this kind of an application, we need to go for a mechanism. So this is the logic which we have to be taking care about it. So this is the logic which I have been taking, and this is the mechanism for the CNN. Now I'll show you the diagram which the CNN works properly. Not a diagram, a video, right? See, please watch this. Right. So the cameras is making over here. So what is the logic here is you can see here the difference of this first image and the second image, right? So the logic which comes into the picture here is this is the mechanism and the skeletonization is being taking over here. This is what we call the segmentation, right? This is called the done by the segmentation and your what we called as done with the help of a pooling layers and the filter banks. This is an exact thing what we can done with the filter banks. So what happens is that every background image is being separated. So every background image is separated and you can see this, all these things are being removed and you can see only the skeletonization. You can see only the skeletons. So this has been done with the help of a filters. So applying the filters over the image, I can able to get. So this in this image processing, we call this as a skeletonization, where I'm going to get only the skeleton images, where I'm going to get only the skeleton images is being possible. Now I'll play this. Now you can see here there is a red dots over in the skeletons, right? The red dots I need to extract because the scene will give you like it has to sync with the human walking. Okay, it has to sync with the human walking. Now what happens is now these points has to be adjusted. These points has to be adjusted clearly. So I need these points actually. The skeleton is extracted, the skeleton is segmented with the filters and everything. Now I need this only these points for an extraction, for the better manipulations. So that is being done with the help of your pooling layers, right? So arriving only one certain portion, what is required, right? In the first case, filters will give you all the things which is required. But in the second case, I need what is the required image which is required, that is being segmented here. So you can see a red marks over the joints because it has to sync. The motors has been fixed on that and it has to sync with that kind of an application. So you need to understand clearly. I need that points alone has to be extracted. For that, we have to use a pooling layer. And the pooling layer will have the max and min layers, which is to be substituted for your application. So this is the logic which have to be taking over here. Yeah, you can see here all these things which is required, all these joints which is required, everything you can see here, and that points will give you an understandability that this is the pooling layer and these features are extracted and utilized for the training. So this is how the application works on. So now, so hope you have understood what is it is exactly is all about and how it functions actually. So now I'm just going for a methodology. So this is the logic, what we have seen in numbers, we have seen visually. Now the logic, the programming mechanism, where it does and what it does, and what is the problem you are facing over here. We talked in the earlier case, it is a convolution extractor with NN layers, right? So the NN full connected layers. These NN layers will be normally done in the traditional cases, will be done with the back propagation cases. The back propagation, what do you mean by back propagation? That is NN layer, output is fixed, and we'll check whether the output is obtained to the threshold level. If it is not, the error will be taken as the feedback and we will tune the hidden layers. The nodes which is present in the hidden layers, that is nothing but input bias. So the bias weights, right? Bias weights has to be adjusted according to the application, according to the error. Until that error is nullified, I need to tune on this kind of a mechanism. It is little bit complex, but still we can able to achieve what is the performance we can make it out. But here, this complexity and mechanism will take a lot of time. Nowadays, we are just moving on to the next methodology, the NN layers, something on modification, NN layers with forward. Something on the hidden layers on the feed forward mechanism. So the logic which comes into the feature extraction here is a feed forward mechanism. The feed forward mechanism is important, very important for this case. Here there is no kind of a feedback and it can able to get it with a different input. That is, with the inputs it can able to assign its own bias weights and you can get a good performance. And from that we have another classification, another methodology where the CNN is being changed right now. So convolution neural network. Now the NN layer has been now converted into PLM layer. This is the logic. ELM is the extreme learning machine. This is the most advanced technology or most advanced mechanism where I just hybrid one machine learning algorithm over the deep learning mechanism. So this is the logic which we have to be making. ELM is the extreme learning machine, and it is single feed forward network. It's a single feed forward network which has to be identified for a mechanism. It has to be identified for the mechanism. It's a single feed forward network. So it's a single feed forward network. So they have a lot of layers which is to be worked on this ELM. Even though it has been only in 1997 it was found, but still it has been playing a vital role along with the deep learning algorithm. Now this is one kind of, it's a single feed forward mechanism where the input bias and weights has been assigned randomly, or auto tuning of the bias weights will take place. So this is the logic what we have to come across with this kind of an ELM layers. And now again the traditional, again we are going for a changes. The change here is something different over here. And what I'm going to do here is I'm going to integrate with convolution features along with an SVM. This is another hybridization what we have right now for video processing, where the convolution features along with the SVM. So the dense layers of convolution features will be given for SVM to learn. So now there is a hybridization of the machine learning over the deep learning logic. So this is all about the formation of a new algorithms. So first thing is about the simple NN layer BP, and then convert into your feed forward. And what is having in a feed forward is something again we convert into ELM. And the next thing is about SVM. So this is a logic like we have converted your machine learning integrated with the deep learning mechanism. The training model is being now replaced with your application, with your machine learning. So convolution neural network can be converted into convolution support networks, where it is consist of the convolution feature extractor along with the support vector machine for the training the mechanism. So this is all about the training model. Now again I'm going to change it. I'm going to change the model. You can have the video again for you. Again a video. So I'll play this video again. Right, it works. It's a supervisory model. What happens is it gives an instruction. Now the instruction is fixed that it can walk normally like a human, right? So now we talked about, let us assume CNN and SVM is utilized, and we are working on a supervisory model. So CNN and SVM is utilized, and we are working on the supervisory model. So we have the supervisory model with us. So these two models have been fixed, and these two models have been fixed, and this is the logic which you have to be taking care about it. Now, with the help of this SVM, now what happens? It is supervisor, it works accordingly. Now, right? And my model is now interacting with the environment, right? Now, my model is now being interacting with my environment, right? That is this Vasigaran. And he gets the input. It gets the input, right? And he adjusts itself. The model is adjusted according to the input what I obtained, and it works accordingly. And this is known to be the reinforcement learning logic. And this is known to be the reinforcement logic. Nowadays, the deep learning has been changed into the reinforcement mechanism, has been now changed into a reinforcement mechanism. So this is the most important. I repeat once again, when you see this thing, the robot walks, machine walks with its own style. That is supervisory model. Now what happens is, this model, machine model, interacts with the environment, that is nothing but with scientists, and get the information. And from the information, what it does, it tunes its input weight so that it works accordingly to the environment. And that is known to be the reinforcement logic. You can see here. Yeah. So you can understand from the walking style here itself. Yeah. This supervisory model, it works. It doesn't synchronize with the input. It works accordingly. It works like a human style, right? It's synced it. Now it interacts with the environment, and it adjusts its input bias and works accordingly. So this is the reinforcement. It's a self-learning and self-adaptive learning logic. It's a self-learning adaptive logic, which is to be taken over here. Self-learning adaptive logic is important. Once again, I'll just. So now we have logic that we are converting into this mechanism. Everything should be like features with SVM, but should be learned in a reinforcement. Most complex, but still more powerful. So when you want to work on this kind of an application, I suggest you to go for this convolution feature with an SVM. So this is the logic, not an SVM, any learning model, but in case of the reinforcement mechanism. If you go for this kind of an application, my machine will have the self-adaptive understanding, self-adaptive. Then it's able to update. So it is utilized for the dynamic environment. The situations are not okay, right? Where the situations keep on changing it. So like this is the logic which we have to utilize. So convolution. So these are the alteration, or we can say the modification of each and every algorithm. So the convolution features, and now we are been working on the self-adaptive deep learning algorithm. That in short we can say the new modified algorithm in which I just integrated this convolution features along with the SVM support vector machine, and from the support vector machine I can able to make it learning in a proper way, and that too with the reinforcement mechanism. So this is what we call as the reinforcement mechanism. This is the logic what we have to take care about it, and we have to do it. So here again there is another modification what we have, and what is the logic which we have to take care about it. So now the things we have understood, the cycle of learning models to be changed. So now like how you can change this, right? How you can make it out in a simpler mechanism. There is another categorization of a mechanism, again a convolution feature, because we have never talked about the impact of the features. So here the features again about the reinforcement, again apply any meta hysterical algorithm. Have a lot of things. Select your feature which has the impact on training, you can select it, and then you can go for a training. Now this is the logic. So another thing which comes into the picture is you can have the different feature maps in a one-dimensional array, and from the feature maps you can see that from the meta hysterical mechanism, from the meta hysterical algorithms such as PSO, particle swarm optimization, and colony optimization, and bee colony optimization. Nowadays we have whale optimization, eagle optimization, lion optimization algorithm. So these algorithms can be integrated, and you can select the best feature and you can train it. So this is another categorization of the hybrid mechanism, where you can hybrid the different sort of things to form a new network. So that is the logic which has been taken over here. So now this is all the things, possibilities, and then you have a different possibilities also to do that. And all these things, how can I deploy it? How can I deploy in the real-time scenario? So this is the logic. I'll just explain you the step-by-step mechanism. So the deployment, you have, we talked about, you have a huge data, huge things, all these things to be done in the programming sector. So how to deploy it? So first we'll talk about the hardware centric. You have the two pieces with the hardware centric. I talked about previously, a hardware centric mechanism. So hardware centric mechanism. So I told you like we have a CPU, the cameras, and the cloud. Cloud, and then we talked about like when you have a mobile app. You can have this mobile app for a solution. So you can have a mobile app for a solution. So now how can I able to do the logic? How can I make it a mechanism which I can do it? So now for this kind of the CPUs, what we require and what is the logic which is required, we have to take care about the mechanism. We have to take care about the logic, and we have to take care about the mechanism. Now, so here the hardware centric, the CPUs. Systems, right? The camera systems and CPU. So let us assume when you work on the CPUs, you must have this kind of an application. What is the memory which can able to withstand? So you must understand the architecture, what we talked previously. The architecture memory mechanism. Here, many of us will be committing a mistake. What we do is we want to train our machine in the machine with the models which we require. But if that memory kind and everything cannot be utilized over here, so I suggest you to go for two important methods. One, use your Google Colab. Google Colab or paper spacing. Train the model, what is required for you, and have this H5 file and store your H5 file in the hardware and test it. So this is the one kind where you can use it. So if you want to, if you are using low weight CPUs, right? Low weight CPUs, you can use this. So because the architecture is very limited and memory, if you have large memory, no problem. But for this cases, you can train your model in a Google Colab or a paper spacings. Sorry for the typo error, and then train the model and get a H file and store the H file in the hardware and test it. This is one kind of mechanism where you have lower limited CPU resources. When you have huge mechanism, just GPUs. The Jetson Nano will have this CPUs, that is embedded GPUs, and then this can be done. All this can be done in the hardware. So this is the logic. All these things can be done in the hardware. All these things can be done in the hardware. So the GPUs and this kind of mechanism you can do with the kind of an application, or we can make it out. So why I'm suggesting to go for this? Otherwise, you need to develop a system, and that system should have all the GPUs which is going to be mentioned. So I'll explain you one by one. So this is how the logic. So first, when you are doing with the low CPUs, such as Raspberry Pi, or such as the MaxiPi boards, what I told you, and these boards will have only the limited memory, and these are the things which has been going outside. So I suggest you to go for this Google Colab for training your model, download your H5 file, store the H5 file in the hardware and test it. And when you want to do everything in your devices, I suggest you to go for a GPU, and GPU that is embedded GPU. The best example is NVIDIA Jetson Nano. Everything you can do it in the hardware itself, that is in your GPU itself. So this is the logic. So first thing, this is the logic. So I suggest you to go for, if you are lower end version, we go for a Google Colab. This is the first kind of deployment. And second kind is, if you don't want Google Colab, or you want your standalone station, then you have to work on this mechanism. You need a huge GPUs to store it. So huge GPUs. When you want to have your laptops, please have aware about that. You have a GPU with NVIDIA. And then finally check with the huge RAM. I just go for i7 or i9. So this is the logic I used to go for it actually, right? Because a little bit costlier for training it. And then you need at least 16 or 8 GB of RAM. And GPU, like it should be like 2 GB or 4 GB. Just work it on this. This is a very simple configuration to train your model in a standalone system. But replacement will be a little bit costlier. So if you want to train your model with the existing system, I suggest you to go for this mechanism. Go for it. Google Colab, train your model and store the H5 file in the hardware and test it in the particular hardware. Otherwise, you have to buy this GPU and you have to train the model in the GPU, and then you need to put up on all these cases. So the best example is NVIDIA Jetson Nano, particularly for the video processing, right? You can utilize this. And for this kind of an application, when you want to develop this kind of an application, you can use this board. I told you the architecture, that's RISC-V architecture. Any board with the RISC-V architecture, you can integrate a live streaming of video for the analytics. So the RISC-V architecture is utilized, and then we can able to utilize, and then we can RISC-V architecture. And the best board, what I told you, is MaxiPi. MaxiPi board. So this is the logic what we have to come across here. So these are the things which we have to take care and do the application. So these boards have been utilized when you want to make it a RISC-V architecture for video streaming, and when you want a GPU, I suggest you to go for a NVIDIA Jetson Nano, right? So or else if you are been uncomfortable with these boards, you can start trying with the Raspberry Pi. So these are the things which is being utilized for a kind of an application. This is pure on hardware centric. When you want to develop a kind of a model, what we talked about, it is pure on hardware centric. Now the second application is a software centric. What you can do with the software centric applications. For the software centric application, right? So the development, for the deployment, I suggest you to go for a camera and then a CPU and then you can go all sort of stuffs in the cloud analytics. Cloud analytics can do the lot of applications. So all these things will be done in the cloud. Let us assume how it can be done with the Google Analytics. Here, the Google Analytics, and we have this kind of application. Then we have an open ML model or auto ML model. The auto ML mode is being utilized in all sort of application when you use a Google Cloud for your analytics. The open ML or auto ML logic is nothing but the integration of a machine learning. Already the predefined libraries are there, and you can use that libraries for a kind of an application. So you can utilize for a kind of an application that is known to be the auto ML. There's a group of libraries where it is in Python or Java or any cases, or you can utilize with this kind of an application. So this model is being utilized. Auto ML concept is being utilized for a kind of an application. What is the major drawback here? We can't able to implement our own model. If I suggest you to in the previous model, I just go for this kind of convolution feature, meta-hysterical and feature selection, or I want to combine this convolution with SVM with the reinforcement. You can't do with that. So what is the mechanism is you can try with the model what is being present over in the library, but you can't do with the model which you want to try it in the new cases. If you want to put up a new model for it, it is a little bit tough. So there is only a beta version which is available in Google Analytics, and you can work over here. So this is a logic which we have to be taking care about the mechanism, the Google Analytics. And when you want to integrate with this, I suggest you go for AWS or Azure. These clouds will provide you an ML approach, and most probably with this kind of approach, all the things what we are making out, what we are witnessing is implementing our own new model in the cloud will be having their own drawbacks. So they will have their own models, which you want to work out this, they will have their own model. When we want to implement an own model, they have their own drawbacks with this. So I suggest you to go for the first case, because this is most important. But what is the major drawback here is every time the model needs to get updated. And that is, we talked about reinforcement, and bringing the reinforcement in kind of a hardware is a little bit tough. So that is the most important complexity what we are facing today, right? So, and how it is implemented. So now we have seen here how it is being implemented here. So now the implementation, the deployment can be done in two mechanisms. The implementation is a program. So I suggest you to go for a Python. So when you go for a kind of a GPUs, when you want to work on the GPUs, I suggest you to go for a Python. And nowadays, hardware centric is now it has been converted into the MicroPython. Everything is now converted into a MicroPython coding. So the MicroPython coding is completely of the hardware centric logic. It is completely with the hardware centric. So hardware centric is nothing but a mechanism which we have to take care about it. A hardware centric relating with the memory architecture. We need to write a Python code, and that Python code is a MicroPython. It's nothing but a combination of a C programming and the Python mechanism. Python mechanism, the C programming and the Python mechanism will taking into a feature. This is the logic. So combining the features of C and the Python as we know about it. So here, when you work on the GPUs, I suggest you to go for TensorFlow, Keras, and even PyTorch. These tools can be implemented in an embedded GPU. What we talked about here, Python with all this TensorFlow. But when we work on this kind of hardware centric, I just used to go for this TensorFlow Lite. Mobile Nets, an example, right? This is for the lightweight hardware. If you talk on the previous case. So this is the lightweight hardware. And when we saw about it, what is the drawback here? You won't find much support from this kind of application because it's still developing. And when you saw this, you can have a huge number of support over here, and you can develop your own application for a mechanism. So this is how the logic works on. So the implementation can be in two mechanisms, and in cloud, I told you it is preferably open ML. It's an open ML or a auto ML logic where it integrates with the kind of your the Python programming with the predefined libraries, and you can use it. But the drawback is when you go for a cloud-based approach, integrating our own algorithm and the cloud makes us to a little bit tricky here. But when you work on this kind of an application that is work on the embedded GPUs and connected with the hardware, you can design your own hardware, or you can design your own algorithm and fix it for a certain application. So this is how the logic works on. So this is the logic which has been working on the kind of a mechanism. So here, this is the logic. I hope you can understand what is the mechanism. It has been done with the implementation. And as far as this is concerned with the video processing, we have seen the video processing with an application like called the facial recognitions. The facial recognition is in a part of video processing, but still in this application, we have seen that facial expressions or facial recognitions and different kinds of feature extractions and everything. And we have formulated a new algorithm which is being taking over here. Now there is another category of a video processing which is primarily utilized for a kind of the documentation, reading a document. We need a device where I just fix up the camera and just read it, the document, and make this intelligent devices, right? So this is primarily utilized in a kind of an archaeological survey where I just read all the data and store it on my cloud and just compare it what is happening, and then I'll just predict what is the meaning of the real or the essence of the real sentence which is present. So these kind of algorithms is being utilized to dig out the older version or older structures which is there in the older structures before 2000 or 3000 years ago. We want to dig out what is happening, and what I'm going to talk about is going to be like will be involved for such a kind of an application. So other than this facial recognition, we come to this point and the feature extraction. I used to go for this guide analysis. Walking style has to be recognized. And diagnosis of anything, right? Diagnosis of your behavior. And the face expressions, you can use it for diagnosis of different disorders through facials. Then another area where it is going here. Right? So these are all the things, right? So these are all the things which is required for you. So the other than this, we have this identification, and moreover, when you want to work on video processing, please remember all these points. And now I'm going to show you another thing, another application, the most important application, and how the algorithms formulated for a mechanism. This is whenever you go for a research or whenever you want to go for the document reading, I suggest you to go for this method. An example again. I'll play this video again. The understanding of the letters through the images. So the first is facial expression is done. So the most important, camera reads your documents. The images have been extracted and the sentence has to be read by the machine. The most important application. So here, I'll stop here again. So here, this application, right? Facial emotions, right? Facial emotions and different. I'm just going to concentrate on the documentation, right? How the machine reads and what algorithm can be done on this. So machine reads the document and understands through the cameras. How does it understands all these things? So here the camera captures it. So I'm just going for only the page has to be determined. So I'm going for a convolution network. I need to train it. I need to train this. So for this, I am just going for the LSTM network. So there is another combination which comes into the picture. So the convolution, with help of a convolution, I can extract the letters. I can able to extract the letters. But the thing what we are going to come across here is I'm going to implement an LSTM. You have a lot of things. This is what we called as in this. We have a lot of things for a sentimental analysis, whether the document or whether the document which contains sentence is good or bad, or we can able to predict the next sentence and read what is what. So here in this kind of a things, I'm just going for the LSTM network and with a model of birth models. the BERT model is being utilized here. The BERT is nothing but bidirectional encoders for receiver and transmission. Okay, receiving and transmission. This is a library which works on the LSTM for a kind of understanding your words, right? We can call this as the words into vectors. That can be done here. And from that, the LSTM is utilized for the training and the prediction of the sentences. So this methodology is utilized here. And now what is the problem here is, once it reads the first book and it goes for the next book, right? So what happens is, there may be the common sentences which is available over here. And the problem comes across is, every time it reads the books, it should understand this sentence is present in the memory already, and it should correlate with the sentence. So this is the intelligence which we are working today. The research challenge what we are having today is this. That is, I repeat once again, you will not work on the traditional method in such as that in the traditional method, read the first book, understand it, read the next book, third book, fourth book. That is not the case here. If I'm keep on making it, the memory size and everything keeps on increases. So in order to make a better understandability, it reads the first book. It captures the knowledge with the LSTM and predicts the sentence and keeps on it. And second thing is about it needs the next book. And the next book, what happens here is it has to correlate with the first letters, what the first sentence which is present. For example, he was good. He was good was the sentence which is present in the second book. But it should understand this was present in the first thing, and it should correlate with that. So this kind of intelligence has to be done in this case. And for this kind of an application, we are just moving on to the next level. That is CNN, LSTM, the kind of, now the LSTM is now replaced with transformer neural network along with the reinforcement, or we can say meta-hysterical reinforcement. This is a little bit complex algorithm. So this is the logic which we have been taking for the real-time application. So real-time application, this is the logic which we have been taking care for the real-time application. Now, this is the new model which we have been working over here. So for the documentation, you can try with a single LSTM and the BERT models, and you can come out with it. When you have a real-time scenario to work with it, it can go for in and out, left and right and left. So it has to understand the research problem. I told you the challenge I told you in this is that is, if it has been stored and it has to correlate its knowledge, it has to improvise its knowledge based on the data stored. So this is the most challenging effort what has been taking place in this kind of a machine. So machine-based reading with the help of a vision system. So this is the logic which you have to be taking care about it. So the CNN with the TNN algorithm, that too with the meta-hysterical reinforcement mechanism has been integrated, and a kind of a deep learning which consists of all sort of application to work on this mechanism. So this is the logic which we have to be taking care about the mechanism. When you talk about a vision system or a camera system, this is the algorithm. These are the algorithms, the latest and updated, complex, but still it can be implemented. So these are all the things which are I've been doing here for the facial emotions, documentations, everything, applications, everything can be done with the help of this algorithm. This is how we started with the basic SVM. Now we have concluded with something on the hi-fi CNN, TNN model with a meta-hysterical reinforcement, which is considered to be the most complex algorithm for this kind of an application, right? So I repeat, I just give a nutshell. We started with what is AI and everything, vision system. When you the points to remember, once you start with the video processing, the preparation of a training model, how to prepare for an example, selection of a model, and then you have all sort of deep learning models, how to select it and how it works with CNN, and how the CNN is converted for the different hybridization and the different application, how to deploy it, what is the programming technique you have to integrate it, and finally the documentation, how to make the machine to read with the vision system, and the challenge what I posted and the solution what we have. So this is a kind of a 1% coverage. You have 99%, right? With all the seeing the movie, I can able to derive and show you it. So better understandability has been done over here. If you have any queries, kindly ask me. Any queries? Any queries, guys? Any doubts actually? So I leave it for you actually for the query session. You can ask me any doubts. We can store the data in GPU. Yes, that's what we talked about. We can store the data in GPU actually, and depends upon your application also, right? That is most important, because we talked about like the cloud also, the storage of cloud is also required for that. But when you use a high-end GPUs like what we talked about, you can store it in the GPU itself. Any doubts here? Thank you. Any other doubts? Any doubts? So you can share your doubts in this mail also, my official as well as my personal mail. May take some time to reply it. So sorry for that. May not reply immediately. It may take some time to reply back. So maybe Chennai at Gmail. So you can mail me whatever the doubts you have, and so that I can help you out for the cases of an application, right? So any doubts also, like you have 5 minutes time, you can ask any doubts also. Okay, if there is no doubt, we can conclude here, right? So we saw, I have shared everything with you actually, what we are working, what is a real challenge, and I just discussed everything, what is there in the market. So it is up to you to start with it and like do it. So anything which you have been like been stuck out, please contact me through mail so that I can help you out. I'm happy to help you out for any case, but it will take time actually, right? So that's a logic, and hope you have enjoyed it with the kind of a case studies with the videos and like in the whiteboard session instead of full PPTs. Like, so hope you have enjoyed it and learned something else from the session, from my session. So I hope that everyone like should come with flying colors, with a lot of research, a lot of products and everything. If I'm the part of that, I'll be very happy for you to do it. Okay, so thank you, participants, and thank you, PIT, for giving me this opportunity to share my experience with you guys. Thank you and best wishes.